Hello everyone, my name is Abhishek Bagel and I'm a mathematics teacher. I teach Foundation and IIT-JEE both. So in today's session, we'll start with the very important and very interesting chapter, that is function. Function is really important, easy as well as very interesting, right? So without any further delay, okay, we'll start with the session. So first thing is function. What is function? So function is basically it is a type of relation. So it is simply a relation in which every element of every element of set A gets related to exactly one element of set B. So two conditions are very important. Every element of set A gets related, and the second one is to exactly one element of set B. Okay, if any of the relation fulfill these two conditions, then we can say that this relation is a function, and it is written as function f defining from side A to side B. Okay, let us understand function by having one example. Clear? We'll understand this by having an example. Let us take one example. Let's say we have a relation. We do not know whether it is a function or not. We have seen that. So every function is a relation. Function is a type of relation, but not every relation is a function. Okay, and we have seen that which relation, which conditions must be fulfilled by a relation to become a function. So we have a relation defining from side A to side B. Clear? The elements of side A is nothing but what? Let's say 1, 2, 3, 4, and the elements of side B 1, 2, 3, 4. 1 is related with 1 and 2 is, let's say, related with 4. Clear? So this is how we write it: 1 related with 1, 2 related with 4. Clear? Now we'll see. Okay, this is a relation, no doubt, but whether it is a function or not, so we need to check two conditions. Every element of side A gets related, and then related to exactly one element of side B. Okay, first thing, every element of side A gets related. So you can see that, okay, 1 related with 1, 2 related with 4, but 3 and 4, they are not at all related with any element of side B. So here, not every element of side A gets related. So we can say that this is not a function. This is not a function. So it is not a function. It is simply a relation, basically. So it is a relation, but not a function. It is a relation, not a function. Clear? We'll take one more example. Let's say we have one more relation, this defining from. So let's say the elements of set A is nothing but what? 1, 2, 3, 4, and then 1, 4, 9, 16, 25, 36. Clear? 1 related with 1, 2 related with 4, 3 related with 9, and 4 related with 16. This is a relation, right? But we have to identify whether it is a function or not. The first thing, every element of site A must be related to exactly one element of site B. So you can see right here, one related with C. Here 1 related with 1, right? 2 related with 4, 3 related with 9, and 4 related with 16. So all elements of site A gets related. So first condition is fulfilled. The second condition, they must be related to exactly one element, not more than one element of site B. Exactly one element. So 1 related with 1 only, 2 related with 4 only, 3 related with 9, and 4 related with 16. So every element gets related, and they related with the exactly one element of side B. So we can say that this relation is fulfilling both the conditions, basically. Clear? So we can say that this relation is a function. This relation is a function. So it is a relation as well as function. It is a relation as well as function. It is a relation as well as function. All functions are relations, basically, but not all relations are function. Clear? I hope function is clear, right? So what type of relations must be a function? Clear? So two conditions must be fulfilled. The first condition is every element of set A gets related, and the second condition, they must be related to exactly one element of set B. Clear? Okay, let us talk about the range, domain, and codomain of function. Clear? So we have a function, right? We have a function defining from set A to set B. Clear? Set A to set B. Codomain is nothing but what? Codomain is the set of the elements of side B basically. Codomain is nothing but what? The side B only. So B is the codomain. Codomain. Clear? It is the codomain. Codomain is always side B, and then we have the domain. Domain is nothing but what? Domain is the set of elements of set A which gets related. Which gets related. In function, in case of function, all elements of set A gets related. So we can say that in the case of in the case of function, this set A is nothing but what? The domain. So set A is the domain always, because domain is the set of elements which set of elements of set A which gets related. Clear? In the case of function, all elements of set A gets related. So we can say that this whole set A is the domain. So in case of function, whole set A is the domain, whole set B is the codomain. And what about the range? Range is the elements of side B which gets related, right? Which gets related. Elements of side B which gets related. Clear? So let us now find out the domain, codomain, and range of both of these, okay, relations or functions. Clear? So yeah, see. The first one is not a function. It is a relation, but we can find out the domain, range, and the codomain. Clear? So domain of this one, the first one, the domain of first one, domain is the set of elements of set A which gets related. So domain is nothing but what? Set of elements of set A which gets related. So 1 and 2 are related. So domain is nothing but what? It is a set of 1 and 2. Right? Then we have range. Range is the set of elements. So this is not a function. So I should write here, let's say, this is simply a relation. So dr and rr. Clear? Range is the set of elements of set B, right? Set of elements of set B which gets related to set A. Clear? So it is nothing but what? Inside B, 1 and 4 are related. So 1 and 4, right? Set of 1 and 4 is the range. While codomain is nothing but what? Whole side B is the codomain, whole side B. So it is 1, 2, 3, 4. Codomain is whole side B. That's it. Clear? Whole side B is the codomain. Sometimes, okay, we call this side B. Side B is the image, right? And side A is nothing but what? Pre-image. Pre-image. Clear? The second, the example we have taken with the second example, okay, it is a function basically. Now let us find out the domain, codomain, and range of the second example, which is a function. So yeah, here we have. See, so domain of this function, domain is the set of elements of set A, right? Which gets related. It is a function, so all elements get related. So it is nothing but what? Simply a set A. Whole set A, which is 1, 2, 3, and 4, right? And range is the element of set B which gets related. So it is nothing but about 1, 4, 9, and 16. And then codomain is nothing but what? Always it is whole set B. Clear? Which is 1, 4, 9, 16, and then we have 25, 36, and so on. That's it. Clear? So I hope, okay, everyone is cleared with the function, the domain, codomain, and the range. Clear? We'll now move forward with the next part, that is types of function. Types of function is also very important. We have understood the function, what is function, and how we can identify whether the given relation is a function, means which two conditions must be fulfilled by a relation to become a function. We'll now see the types of function. So write down the second, the heading, next heading, which is nothing but what? The types of function. Types of function. We'll see majorly, okay, 4 types, right? Four types of the function. Okay, let me write down the names first. First one is 1 onto. Second one is 1 into. Third one is many onto. And the last one is many into. These are the four types of the functions. So any function you'll get what? Okay, we can classify it, okay, any function in either of these four categories. Fine. So let us understand all these types of the function. So we'll take one example. Okay, let's say we'll understand the types of functions. Okay, I'll make you write down, okay, the types of the function at the end. Right. So first, okay, do understand the different types of function, because the functions are very important. Student, okay, might get confused between different types of functions. So you need to, okay, understand. Okay, just pay attention. Okay, don't write anything. Okay, I'll make you write each and everything, each kind of functions at the end. Clear? So first, okay, just have a look at it. So let us understand this by having one example. Let's say we have a function. So now we are talking about the different types of functions. So we'll take what? Only functions only. Okay, whatever relations I'll take. Okay, all these must be what? A function. Okay, you do not have to, okay, check about it. Clear? So let's say we have a function defining from side A to side B. 1, 2, 3, 4. Clear? The side B, 1, 4, 9, 16, let's say 25, 36. So here 1 related with 1, 2 with 4, 3 with 9, 4 with 16. So here you can see, right? Okay, this is the function, right? But so inside, so the definition of the function itself says that every element of sides A gets related. So okay, so we'll define what? Function. We'll classify the function now based on the side B. Basically, you can see that in side B, not all elements are related, right? Not all elements are related. You can see that 25 and 36, they are left. They are not related with any element of side A. Such type of relations are nothing but called as the into. Such type of functions are called as the into functions. So they are into functions. Clear? They are into function, because if at least, okay, one element gets unrelated in set B, if at least one element gets unrelated inside B, we call such type of functions as into function. Clear? And in case of into function, see, range is always smaller than the codomain, right? Because codomain is nothing but what? This whole side B, and the range is the set of elements of side B which gets related. Here you can see that the definition of the into function itself says that, okay, if at least one element is unrelated inside B, then we say that it is an into function. So range is always smaller than the codomain, right? And what if all the elements gets related? Okay, what if all the elements get related? In that case, we'll say this function is a onto function. So we have into and onto. Okay, they are basically opposite to each other, right? If all the elements of side B gets related, we call onto function. If at least one element is left behind, unrelated inside B, we call it as into function. Clear? So let me write it here. Yeah. So here we have the next function in which all the elements of side B gets related. 1, 2, let's say 3, 4, 1, 4, 9, and 16. So you can see that in this function, all the elements of side B gets related. Clear? So such type of functions is nothing but what called as the onto function. Onto function, because all elements of side B gets related to elements of side A. Clear? So it is onto function. In onto function, range is always equal to codomain. Range is always equal to codomain, right? So in case of onto function, because all elements of side B gets related, so range is equal to codomain. Sometimes onto functions are also called as the surjective function. Surjective function. They are surjective function. Clear? And on into function, they are sometimes we call, okay, not onto your or not surjective. right? So we can say that, okay, into function, if it is into function means it is not a onto function. So onto function is sometimes called as surjective function. So into function would be what? Not surjective, right? So it is not surjective. Clear? And in case of onto function, range is equal to codomain. And then we have one and many one, right? One and many one. So let us understand one and many one functions now by taking one more example. Let's say we have we have a function defining from set A to set B, right? Set A to set B. Let's say here we have -1, 1, -2, and 2, 1, 2, 3, 4. Sorry, -1 gets related, -1, 1 gets related with 1, 2, -2, and 2 gets related with 4. So here you consider all the elements of site A gets related, right? And related with exactly one element of site B. So it is a function, right? So don't be confused that, okay, -1 is related with 1 and 1 is related with 1, right? It might happen. So -1 is related with only one element of side B. 1 is also related with, although they both are related with the same element, but they are related with exactly one element. So that's why it is a function. So don't be confused in that. But as you can see, right, okay, -1 and 1, they both related with the same element. So that's why we call such type of functions as many one functions. Many one functions, right? They are many one functions. Many one function, because more than two or more than, if more two or more than two elements gets related with single element of side B, we call such type of functions as many one. And if not, in that case, we call one functions. So here you can see that in the example, in this example number 1 and example number 2, every element of site A, okay, not a single element, not a single pair, we are getting what? The same image, right? This is called as the pre-image and this is called as the image. Clear? So not two elements are getting the same image, right? Every element of site A gets related exactly one element with, and all the elements of site B are distinct basically. Clear? So such type of functions are also called as the one functions. So first one is a into function as well as it is a one function. This is one function. One functions are sometimes also called as what? It is injective. Injective function. They are also called as injective function. Clear? The second one is also one function. The second one is also, it is one function, also called as injective function. Clear? Also called as injective function. While here in this example, you can see that -1 and 1, they both are related with single element. So they are having what? Same image, right? This one is the pre-image and this one is the image. So -1 and 1, they are having the same image. They both are having the same image. Let's say if you, okay, stand in front of the mirror. So what happen? If the mirror functions correctly, if mirror functions properly, then you'll get what? A single image. This is how you can, okay, relate with. Okay, not exactly, but yeah, for the purpose of understanding, you can relate with that. If the mirror is not function properly, then you'll get what? Multiple images. If it is functioning properly, then you'll get a single image, right? If we get a multiple image, it means that the mirror is not getting function properly. So here you can see that -1 is getting single image, that is 1. 1 is also getting single image 1. Although they are getting the same image, it doesn't matter. Clear? So it is also a function and it is a many one function. It is a many one function, and you can see that inside B, 2 and 3, these two elements is unrelated. And we know that if at least one element gets unrelated inside B, we say such type of functions as what? Such type of functions as into function. So it is many one function as well as into function. Clear? So we have what? 4 types of functions basically. We have 4 types of functions. Clear? First, we have seen what? This one, the first one, this one. First one is one and into function. One into function. The second one is one and onto function. Then we have many one into function. This one is many one into function. We'll take one more example. Okay, one example of many one onto function. Clear? Many one onto function. See this one. Fourth example, many one onto function. So let's say here we have side A, here we have side B. -1, 1, -2, 2. Here we have 1 and here we have 4. So you can see that -1 related with 1, 1 related with 1, -2 related with 4, and 2 related with 4. All, so you can see that it is a many one function, right? It is a many one function. Many one function, as well as you can see that all elements of side B gets related. So it is a onto function as well. It is a onto function, right? So any of the function can be classified into either of these four functions basically. One onto, one into, many one onto, and many one into. Clear? So yes, now write a note, a very important note. Student will use it frequently, right? That is bijective function. Bijective function is nothing but what? It is injective plus surjective, right? Injective means what? Injective is 1 surjective means what? Onto. So 1 onto functions is also called as the bijective functions. They are also called as the bijective functions, sometimes called as the biuniform function, or as well as invertible functions. Invertible, right? So biuniform function, invertible function, or bijective functions, they are nothing but what? 1 plus onto. 1 and onto functions. If the function is both 1 and onto, means 1 onto function is called as the bijective function. Clear? I hope, okay, the different types of the functions gets clear to everyone. Clear? Let us summarize it. So we have seen what? 4 kinds of functions basically. 4 kinds of functions, right? First one is 1 and onto function. 1 so it is 1 means we'll get what? 1 and onto means all the elements of side B, all the elements of side B. See, all the elements of side B gets related, right? So it is 1 like this. All elements gets related. See, 1 means what? Okay, not two elements have same image. This is what means 1 Every element has different image. Clear? This is 1 onto. Then we have seen 1 into. Clear? 1 into. 1 into means, okay, so 1 okay, one element gets, okay, left inside B. This is 1 into. Then we have next one, many one onto. Many one onto. Clear? Two elements get related with then they are having the same image basically. And onto, all elements of side B gets related. And the last one, many one into. Many one into. One element gets related. At least one element gets unrelated. So this is many one and into, right? So I hope function is clear. How to identify whether the given relations function is not, it is clear. And we have seen what? 4 different types of, okay, functions as well. Okay, let us take one simple example. See, we have been given a relation, let's say A, B, C, D, E, F, G. Clear? A related with E, A related with F, B related with F, related with G, related with G. So now we need to identify whether this relation is a function, right? So two conditions must be fulfilled. First, every element of site A gets related. Here you can see that every element of site A gets related. And the second one, what? Related to exactly one element of site B. Here you can see that A related with E as well as A related with F. A is not related with exactly one element. It is related with two elements. So it is having basically two image. So you can relate, okay, with the mirror example, right? Let's say if you, okay, stand in front of mirror and you are getting what two different images. It is not possible. It means that the mirror is not functioning properly, right? So it is not a function because A is having what two image, which is not possible, right? It means that it is not a function. It is not a function. Clear? So we can say that this is a relation, but not a function. Clear?